Hello guys, welcome to our last session of Ansible. This is a whole DevOps program. If you are just joining us in YouTube, this should be day 32 of our program. You can check all our playlists. We started this program some time ago and we are gradually coming to an end. And today we are going to complete our session on Ansible. We just have 2 or 3 major topics to handle. We are going to see what loops are, we are going to see what handlers are, and then we are going to see how to handle errors in Ansible. Okay, so that is what we are going to be doing today. I think I have already prepared your environment. Let us move over to our console. This is our AWS instance. We still have our 6 machines that we configured from our last session. The 6 machines are still there, so we are going to be using those 6 machines, and we have our controller. So I have logged into our controller. Here is our controller. All right. So what is the concept of looping? With the idea of looping brings about an advancement into how Ansible codes are written. Now take a look at this code. This is the code that we wrote from our last session. Let us try to see how the code is written. Take a look at a code like this one. You see, in this code, we are trying to install Tomcat, and we are using modules in installing Tomcat. We have used the copy module, we have used the apt module, and we are also using the service module. So we have used several modules here in installing Tomcat. So what if we are to continue using or installing as many packages as possible? Let's take, for instance, we want to install Tomcat, we want to install Nginx, we want to install Git, we want to install as many packages as possible that we want to install, right? If we want to install so many packages, it will mean that we are going to make this code as long as possible. That is, giving the various names of the packages and their put state equals present, update cache. No, we are going to write a very long code. All right, that is a bad way of coding. If you have ever attended any coding session, they will tell you that try as much as possible to reduce your code to contain very few lines. First of all, it will help the execution, the execution system, your computer, to execute your code faster, and then the code will not contain so much space. All right, you make your code as small and light as possible. That is how the concept, that is why the concept of looping is actually coming to place, right? We are going to implement loops. All right, so let us see our first code and how we are going to implement loops in it. Now look at this code. Right, we have a code like this. Look at the code like this, right? We have this code. In this code, what are we going to be doing? We are going to be installing Apache. All right, this is the code I want to show you. Let me see. Now this is the code I intend to show you, right? Okay, look at this code. Okay, the highest thing we are going to be doing here is we want to install tree, the package tree. We want to install Git, we want to install JDK, and we want to install Apache. These are 4 different packages that we want to install, right? If our normal convention of writing code, we will first of all write tree, and then we'll write the the apt tree, write the name equals tree, tree here, and then write state present, write update cache no, and then we come and we take git, take the second line, we take git, we write name git, state present, and then update cache no. Then we take the third one. That means this code, this particular code, will go right down. Okay, so because of the idea of looping, look at what we have done with the code. It is we are beginning like your normal ansible playbook, right? And then we give the name, the module of the playbook, which is apt. Okay, we'll give apt here now. Then we come now to the name. Remember that in our normal playbook, we'll give the name of the particular package that we want to install here. Okay, but when it comes to looping, you will no more give the name of the particular package, because there are so many packages that you want to install. Okay, so because there are so many packages, you're going to put it in curly brackets and in double quotes. Put it in double curly brackets and in double quotes, and then you write item. Okay, when you pass this item, it means the items that are going to be installed are beneath your playbook. You don't know the items. The items are going to be lined up in your playbook. And what are the items going to be doing? All the items are going to be present, which means you are going to be installing all the items. Okay, and you are not going to be updating your cache, and not going to be updating your repositories. All right, that means what will happen? How will you pass the item? If you see any code, if they ask you, how will you know that a code is having a loop? How will you identify a loop in a code? When you see with items, you know that those items are loops. First of all, what is a loop? Let us first of all try to talk about loop. What is a loop? Okay, a loop is an endless cycle of activities occurring. An endless cycle of activities occurring. Now, in a normal circumstances, this code is supposed to execute and then comes and ends here, right? Comes and ends here. In a normal circumstances, if we have to pass a particular name here, then the code comes and ends here. It ends. That is the end of the code, right? Now, but when you put a loop, the code will come, install tree, and then goes back and start from the origin again. Start running again. When it runs the second time, it will jump tree, it will install git, and then go back again, start running again. When you install the third time, it will come and install default, and then jump again, start running, and then goes and come and install Apache. That is looping. That means the code is going round and round and round, installing one thing the first round, goes the second round, install the second thing, goes the third round, install another thing. All right, that is the concept of looping. If you ever hear somebody says something is occurring or executing in a loop, that means it is executing in rounds and taking one and achieving one objective after the other. When it occurs in the first round, it achieves an objective. Occurs the second round, achieves an objective. Occurs the third round and achieves an objective. That is the aspect of looping. Okay, so in this case, we have set the code to loop, and the code will loop and install tree, install git, install default jdk. All right, so this is just the aspect of looping. Everything how you execute the code is the same like how we have been doing. All right, what do? We create our playbook. We are creating playbook 11. We create our playbook. We move to ls, show our playbooks are there, cd2 playbook, run ls here. Our playbooks are there. We have 10 playbooks, so we create playbook number 11, and then we copy our code. So definitely what this code will do, it will install, because tree should already be installed, git should already be installed, default jdk I think should be installed, I think Apache 2 should already be installed. So let's just run the code and see what happens. So how to run our code? We know how to run our code. Don't forget to specify your user. We have a warning: could not match supplied host pattern, ignoring web server. Alright, okay, we have not declared whether we are running in host or we are running in all the playbooks. Okay, so how to run it? I think we should run it in we should run it in all the servers and see what happens. So let us see. We remember we have a web server here, so as our playbook, that means we have to run the code in our web server. You know where our web server was found. You remember how we did this. So if we run ls here, we have group.vars. So where are we running this code? Let's go to group.vars and run it in a group of machines. So we cd to group underscore vars, and then we ls there. So we had web servers. So let us change our file to web servers. Right, we cd back to our playbook, and then we ls here, and then we open our playbook 10, playbook 11 please. Do we have a playbook 11 here? Did we make a mistake? Which playbook did we create here? Let's see. I think I created playbook 11, but I'm not seeing this playbook 10. I am not seeing playbook 11. Playbook 11.yaml. Okay, here is playbook 11.yaml. Okay, so we change this one and put an S. Remember, we solved this error in our last session, and I explained to you how the error, why the error is there. So let us try and see if our playbook will run now. So our playbook technically is running, and it has run on 2 servers as we rightly expected. All those packages are already installed. Okay, there is tree was never installed. So, and git is was also already uninstalled from it, so it is changing all those. So I believe our playbook has run successfully. So let us recap what our playbook has done. Our playbook is running in a loop. That is the most important thing we have to know. Our playbook is running in a loop. What is the new thing that we have just learned here? We have learned that we can reduce the size of our code by using looping. Okay, reduce the size of your code by using looping. That is something you should know. And here there is what what are we doing with this type of playbook? We are just doing one thing. We are installing. A challenge will come. That, okay, not all the times will you want to be installing tree, installing Git, installing default JDK, or installing Apache. There might come a time when you want to maybe install tree, and in that same playbook you uninstall Git, and in that same playbook you install default JDK, and within that same playbook again you are uninstalling Apache. That means something is being installed, another one is being uninstalled, another one is being installed, another one is being uninstalled, right? In that case, what will you do? Because here you wrote present, here you use no. Is there a way by which when the playbook will run the first time, this tree will be installed as present, but when it is running the second time, Git, instead of being present, should be absent? Automatically, can we write a code like that? Of course we can. That is the second thing that we are going to learn in how to write looping codes, right? Requirements: tree needs to be installed, Git needs to be uninstalled, right? JDK needs to be updated, Apache needs to be installed and updated. You see, different needs, right? That is our requirement. How shall we write the playbook? Look at how the playbook appears. In the playbook, this is playbook 12. What are we doing here? We wrote our playbook normally like we write our playbook apps. Now, what is the change in our code? The change in our code is here. We wrote item. That is what we wrote in our first playbook, and then we close our curly brackets and our double quotes at this particular moment. But when we want now to do dynamic looping, this is called dynamic looping, we are going to add dot, and then we put a variable. Okay, we are going to add dot in the middle. We are going to add dot, and then we put a variable, dot, and then we put a variable, dot, and then we put a variable. How is this variable going to help us? Now come down here. You will see maintain your with items as, but now you are going to pass your variables. You can decide now. You change A from tree to Git. You change B from present to absent. You change C from no to yes. So this is where you control now your playbook. If you want tree to be uninstalled, just come here and change this one to present. If you want Git to be installed, come here and change this absent to present. If you want default JDK to be uninstalled, change absent to present if you want it to be installed. So you control now the power of your playbook from this partition here. Okay, so here now the playbook runs and absorb the first line, and in that first line a tree is present. That means tree is going to be installed and no update will be happening. The playbook now runs the second time. When the playbook runs the second time, it takes the second line. The second line says A is Git and B now should be absent. That means Git should be uninstalled. And then the playbook runs again the third time and take the third line. Okay, and A now is now default JDK and B now is absent. So dynamically this playbook will run 4 times, but different actions will be taking place. Okay, let us see how the playbook runs. We create our playbook. Remember, we add web servers here and -u Ubuntu. So we create our playbook. That should be playbook 12. We create our playbook 12. then we run our playbook 12. So this playbook ran here. We have no change here. At the level of git present, false. That means git has already been installed. Our playbook ran successfully. Okay, our playbook has executed very successfully in all our nodes. So we definitely understand what the playbook has done. The difference between this one and the first playbook is its dynamism. Okay, so a question in the interview session, if you are asked to perform a series of plays in which packages are supposed to be installed in servers, and you need to write a playbook, and in that playbook some packages are supposed to be uninstalled, other packages are supposed to be installed, and some repositories are supposed to be updated. How are you going to go with that? Your answer is you are going to write a dynamic looping playbook. In that dynamic looping playbook, you are going to define the items and specify their variables below with the hashtag with items. Okay, that is your answer. When you practice this, of course you will know how to really answer your questions. The key point here is when you practice some of these things, when they ask it in the interview, you explain what you have been practicing, which is very easy to remember, because go cramming what you are reading you can easily forget, but explaining what you have been performing is the key way. Okay, all right. Now here there is something we have done. We have only used one module, which is the apt module. Okay, we have used the apt module. The question might arise, can we also use looping with multiple modules? Because here you technically see that we are using only one module, the apt module. Can we use modules with looping with multiple modules? Of course, yes. This example actually tells you that you can use looping with as many modules as you want. Okay, look at the requirements here. Create multiple users. You want to create many users, right? And file directories in users home directories. Okay, you want to create multiple users and file directories in users home directories. Okay, so this is what you are going to do. So the first thing is you are going to use the module user. That's the first module that you are going to use, and then the second module you are going to use is file module. So the user module is going to be creating users, and then the file module is going to be creating a particular file in the user's home directory. Okay, when you create a user, you create a file in that user's home directory. Okay, that is just what we are trying to do here. So how shall this one work? In the first one, we have our user. The user module is creating users. We don't yet know whether how many users are being created now, but when we come to the position of items, because the first one is the name of the user enters here, A takes the name of the user, B takes the password of the user, and then C takes the home directory of the user. So for the home directory of the user, you see this is the home directory where the user is found. This one is the home directory where this other user is found. This user should be, I gave this user should be Eglan, and this user should be good. Now this folder is going to be created in the user's home directory. Okay, the file f1, this file like this, the file f1 is going to be created in this directory here. Okay, this is the new users directory. So how many users are we creating here, guys? How many users do we want to create? We are creating 2 users. The first user's name is Declan. Okay, this user Declan, the playbook runs for the first time, and the user Declan is going to be created. Okay, and then the playbook runs again for the second time, and the user Kiba is going to be created with the home directory. The user Kiba is created with his home directory. Then the playbook runs now for the third time, and a file is copied. Okay, a file is being created, not copied please. A file is being created in the user's home directory. Okay, that file is f1, and then the playbook runs for the last time, and another file is being created in the second user's home directory. All right, so this is how the looping runs. So you can use multiple modules. It doesn't mean that you can use only one module as apt, but you see, if this playbook was to be written without loops and you are creating all these 4 things, the playbook will be almost 1 page full. It will be so much, right? So we use looping in order to reduce the length and the largeness of the code which we are using to write our playbook. So let us create this playbook, guys. So the playbook is going to be installed in all hosts, all of them. All right, so we create playbook 13. Then we copy our playbook. This is our playbook. Let's save and we quit. Now we execute our playbook. Remember how we have to execute our playbook. In system -u Ubuntu. So our playbook is busy creating our users. Okay, it has run in for 6. All the 6 machines are okay. Now it is creating. So our playbook did created all our users, and all these users were created with the file copied successfully without any problem. Field equals 0. So our playbook ran successfully, right? So we can use the idea here is you can use multiple modules in a particular loop. You can use multiple modules. All right, okay. Now we come to the second concept of our lessons today: handlers. That is all about loops, guys. That is all about loops. We are finished with loops, so we come to the second concept, which is handlers. All right, what are handlers? What are handlers? You know, whenever a code runs, it terminates and you don't see anything. If this code runs like this, we do not specify anything. When we run this code, everything runs without any problem. Okay, everything runs without any problem. But who can guess what can arise as a problem? Something can arise as a problem, right? For example, take the code where we update, where we use what did we use there? We use the source module. Now look at this. look at this code, right? Now, if we run this code here like this, when Tomcat has not been installed, what will happen? This code will fail, right? If you run this code, let's take for example, you just run this code, you run this particular code here like this particular code, this one, you run this code, this section of the code, and instead of Tomcat 9 we had but Tomcat 8 here. This code will fail. This particular code will fail. Why will it fail? It will fail because this code, you are asking this code to replace 8080 to 1990 in Tomcat 9, not Tomcat 8. What was installed is Tomcat 8, and you are now asking the code to replace this in Tomcat 9, right? So this code will fail, right? So instead of us just allowing the code to fail, we can use what we call a handler. What are handlers? A handler now will tell this code that you are not going to run. This code is not going to run until Tomcat 9 has been executed. If we don't see Tomcat 9, this code, you will not run. Okay? If we do not see Tomcat 9, this code will not run. Okay? That is handlers. So handlers will only run until a particular code has been executed successfully. That is the definition of handlers. They will only, a handler is a piece of code. That means we can call this code like this. We can make it a handler. That means this code, if we make this code a handler, we are going to refer it to a particular code, which means a handler has its source. If its source has not yet run successfully, that handler will not run because the handler will fail. Okay, so this handler depends on a particular code in order to run. So look at an example of a handler here. Let us look at this code. Now look at this code. In this code, what are we trying to do? We are trying to install Apache 2, right? We are installing Apache 2, and when we install Apache 2, we are going to copy a particular content into the web server, right? And then we are going to restart that web server. Now the question is, can you restart Apache 2 when Apache 2 is not installed? Impossible. Okay, you cannot do that. So in order to restart Apache 2, Apache must be present. So instead of just saying restart Apache, we put restart Apache as a handler. Okay, there are very series of situations where you will need to use handlers. Okay, so you can frame an interview question for this one and they can ask it in any way. You know exactly on how to put it, because you know that a handler only executes when a particular code has been executed. Okay, now where is this? Who is responsible for this handler? Who is responsible for this handler? This handler is not responsible that this one must get executed before it is started. No, instead, before this file is copied, before Logic Labs is copied, right? Now listen, who should inform this handler to start executing? Who should inform this handler to start executing? It is not the end of this file that should tell handler to start executing. No, not the end of this code. Instead, it is the end of this code that should notify handler to start executing. Why? Because we need to do everything, execute everything, and make sure that everything is okay and this file has been copied. When this code, you are finished and you are successful, now notify the handler. That means, what are you going to notify? Notify restart Apache 2 to execute. So this particular code here will run and finish and then notify the next code to start. So that is where the handler now picks up. If this code does not run successfully, the handler will fail. So here you do not see any notify here. Don't have the impression that Apache 2 must be installed, then this one starts. If this notify is not here, then the handler does not depend on Apache 2. Okay, so where to see in which code does the handler depends, you will see this notify. All right, so we take this notify and we put here, therefore this handler now depends on Apache 2. So when Apache 2 must have finished installing, it will then notify Apache, restart Apache 2. But the handler is here. That means after Apache 2 must have installed, Logic Labs must have been copied here. Then at that particular moment now, the handler starts. Okay, so let us see how we can use this. Let us first of all create a playbook. We are creating playbook 14, and then we are running our playbook. It runs on all the servers. Okay, let's execute our playbook. So all our instances have executed the playbook. Let's see now our task. So Apache 2 was already installed, nothing changed. File has been copied, that is what has changed. So our playbook is run successfully. Okay, we can test. All right, you can test, but we know that everything ran very successfully. Okay, I mean, I showed you on how to test all these things in our last sessions. All right, now we can take handlers to a whole wide level. Okay, now if we decide that at the end of every playbook, you can run a playbook when you don't know what will happen. Like for example, let's come up here, please. Here now, what if you are doubting? Let's take for example, you are doubting whether you actually want to update the home directory. That is, you want to copy this to your home directory, right? That is, want to copy a particular writing to a web page, to a home web page, but you don't know whether what is installed in that server is Apache 2 or Apache 1. Right? You don't know whether what is installed there is Apache 2 or Apache 1. You can either write a playbook, which that playbook is going to find out whether is it Apache 2 that is installed or is it Apache 1 that is installed, which one of them is installed. And if the playbook sees Apache 1 installed, it will execute. If the playbook says Apache 2 installed, it will execute. Now if the playbook starts running and it discovers that Apache 1 is not installed, it will skip and check again whether Apache 2 is installed. All right, that is our next idea of error handling. Error handling. Okay, we are going to talk about error handling. So look at the way the playbook is constructed. This is the playbook. Okay, in this playbook we are running the playbook in all our machines. Okay, and what do we want to do? We want to install Apache 1. That is what we want to do. We want to install Apache 1 now, but if there is nothing existing like Apache 1, Apache 1 does not exist, then we want to install Apache 2, right? So the difference now with the way the playbook is structured is, instead of writing your code the normal way you used to write it, we have 3 different blocks. We have the first block, then we have the rescue, then we have the always. How is this one working? This is the block that you want. There's the block, that is what you want. Now if this block fails, that means that it is not available. This particular module that you are trying to run is not there. Then there will be a rescue block that will be initiated, and will come to place, right? If this rescue block also fails, right, if this one fails, then there is an always block that will come to act, right? This always block will always rescue the code from failing, which means when you run this code, because if you run this code and Apache 1 is not there and Apache 2 is not there, this code will fail. It will fail. But now this always block now is going to come in place and rescue the code from failing. Okay, because this code, whether this one fails and this one fails, this one will always run. What is this one doing? It is simply checking for our URL. Okay, it's simply running through some of our URLs. Okay, so let us put our URLs there. This should be, we have 6 machines, so we technically need 2 other URLs to be there. Okay, now we'll copy our public IP addresses and we put here. So our public IP address will start from server 1. I have to copy this manually because now because our addresses might have changed. You know, our addresses are dynamic, so they change at any time. Server 2, and last one, server 6. Okay, so this is a code that will always come to our rescue. All right, this code will always rescue us. So what is the name of our code? It handles errors. We don't want any error. First thing we want is install Apache. If Apache is not there, install Apache 2. If Apache 2 is not there, don't show us any error. Check for our web server. All right, check the URL of our web server. That means no matter what, this code will not fail. All right, let us try to see if the code will run and handle our error. That is playbook 15. now we run our playbook. Okay, our playbook has run in all our 6 machines. All right, we are having a failed system. We'll check what is happening there. So you see there is something. Our playbook ran and failed, but it did not actually stop. It continued running. Without the error handlers, this playbook should have terminated here. Why? There is no Apache 1. Okay, the playbook should have terminated here because it will see that Apache 1 is not there. So but the playbook did not terminate, it still continued running. So which means when this particular code failed, this code continued, the playbook continued, and it ended with checking for our URLs, right? And then it gave us an output redirection false. That means it failed, right? At the end of the day, our playbook has run to a completion. You see, our playbook ran at the end of the day and completed. Okay, so with this one we are handling errors. With the error handling, we handle our errors, and our playbook completed without it. There are failures within our playbook, but it did not stop the running of our playbook. It never stopped the running of our playbook. So that's the idea of error handling. Our playbook will never fail. There will always be a particular block of code that will come and rescue our playbook. All right, so that is the end of Ansible for us, guys. This one has been one of the most detailed training in Ansible, I think, and I think I did an effort to touch nearly everything. I did an effort to touch most of the things that are in Ansible. I think if you go through my Ansible training, you can comfortably say that you can write all sorts of playbooks. I think the last question that they might ask you in Ansible and you will not be able to answer is, what is Ansible Galaxy? Okay, they will always ask you a question like, what is Ansible Galaxy, in the interview question. If anybody ever asks you that, what is Ansible Galaxy, tell the person that Ansible Galaxy is actually some sort of an environment where a community where Ansible modules are being shared. Okay, they ask you what is an Ansible Galaxy. If you go online and look for Ansible Galaxy, that's a community where Ansible modules are being shared. You can write your non-modules, please. Ansible playbooks and all whatnot content is being shared in Ansible Galaxy. All right, then they'll ask you, what is an Ansible tower? An Ansible tower is like a graphical user interface, just like I was saying that we are used to the command line, but Ansible Galaxy is a graphical user interface, the version of Ansible which has a graphical user interface used by larger organizations that they use in order to see all their servers, right? You use Ansible Galaxy to see all your servers as they are. So read about Ansible Galaxy and Ansible Tower. So Ansible Tower is graphical user interface, please, not Ansible Galaxy. Ansible Tower is the graphical user interface for Ansible, and then Ansible Galaxy is instead the community where Ansible content is being shared. And then they might ask you, what are Ansible rules? What are Ansible rules? Ansible rules are pieces of code of your playbook, right? There are formats in which playbooks particular sections of playbooks are shared. All right, somebody can write a particular part of a playbook and send to you. Like somebody says, oh guy, I have this particular part of a playbook, I can send to you a role of that playbook. So an ansible play role will be this section of the playbook, right? You can call it a play, or you can call it a host of play, but it is part of a playbook. That's an ansible role. All right, apart from this, I don't see any question again in ansible that they can ask you with what we have done that you cannot be able to answer. Now they can ask you the question, we introduced ansible and we said ansible is a push based architecture, right? That means you execute your commands from the controller, and those commands are pushed to the to your various slave nodes, right? It is a push based architecture. Then if somebody asks you that, what is a pull based architecture? Now a pull based architecture, how does a pull based architecture functions? In a pull based architecture, this is what happens. Now for this one we have this like this, and then we have the controller here. This one, the controller writes its code and push it to all these ones. That is push based architecture. Now for pull based architecture, instead the slaves constantly scan the master. Master, is there anything for us to execute? Master, is there anything for us to execute? Master, is there anything for us to execute? Now when the master finally has something for them to execute, like the master finally has a code, a playbook for them to execute, then they will come and pull the playbook, and all of them will pull it and go and execute it at their various level. But the push based architecture is you write here and you push here. Ansible is push based architecture. Some other configuration management tools are pull based architecture, that is slaves pull from the master. Okay, so if they ask you these things, you should be able to explain it. All right, I think with this we have answered nearly every question that can ever be asked with Ansible, and I hope you enjoy your lessons very well. I hope you practice more and become very strong. With this, we terminate our session of Ansible, and we are going to be entering into Terraform next. All right, thank you guys, thank you very much. Practice, sacrifice, put more effort. See you guys.